In the previous video, we built a confidence interval based around this sample of 100 students, a mean sampling height of 68, and a standard population standard deviation of 3. We found this confidence interval for a 95% confidence interval. I just want to quickly look at what happens when we change that size of confidence interval. So we just found the 95%. We said it was 68 plus or minus 1.96, and then we had let's see, it was 3 over square root of 100. Okay, and the 95% comes from the idea that from the z table, z, maybe we can say z of 95 is 1.96, and all that's going to change when we deal with say 90%. If I can draw a 9 correctly, 90% is we're going to change what we find on the z table. Okay, and so a z, if we look up the z associated with 90, or on our z tables that's 45% and then doubled, that's going to give us 1.6. We generally say 1.645 because it's right in the between 1.64 and 1.65 on the z table, and in fact it does come out clean as 1.645. So we just plug in 1.645. The rest remains the same, right? So the standard deviation of the population is still 3, and we still sampled 100 individuals. Okay, and so this, I guess we didn't quite finish this. This became 68 plus or minus, let me just cheat back here and see what we said it was, 0.588. Okay, and so in the 90% confidence interval, this becomes 68 plus or minus. Now, what do we assume this is going to be? So, if we're building a 90% confidence interval, what we're really saying is that we're a little less certain, right? So you can think of the confidence interval as how confident are you, and if you're 95% confident, you're more certain than when you are, I don't know which one I started with. The larger the confidence interval, or the higher the percentage, the more confident you are. So when we build this 90% confidence interval, it's going to have a smaller window, right? It's a more precise statement, but but we're less confident about it. Okay, so this becomes plus or minus 0.49. About 494 if we want to keep it in the same units. Okay, so and again, you can take this to the extreme, right? So we could be like 1% confident and just say it's 68 plus or minus 0.0001 or something like that, right? So on the extreme end, we're basically just saying, yeah, it's 68, but we're not that confident about it. And we could go the other way and say, well, 100% confident. If we wanted to be completely confident, we could say 68 plus or minus 12 inches, and we'd be pretty sure that we're right. Okay, so and all of this in the middle is kind of playing around with exactly how confident we want to be. So we said the other common one is 99%. Can't use green when we have that chroma key on. Okay, so 99%. The 99%, and you can look this up again on the z table, is the z of 99 is 2.576. Okay, and so again, that's going to be 68 plus or minus 2.576. And then again, this stays 3 over 100. So really, there's nothing. I want to point out that we just calculate. We choose what we're going to, what level we want. Okay, so there's no defined value that this has to be, or confidence interval. Now there are kind of conventions So when you report, polling data, maybe the convention is you always put a 95% confidence interval or something like that. So this becomes 68 plus or minus 0.773. Okay, so a wider range. And so all that changes when we change that confidence interval is the z-score, because we're picking a different level of confidence, and that's going to adjust kind of the band in which we're talking about. So pretty simple to adjust those, and again, it's kind of up to you as the data analyst to do that, to choose, unless there are kind of agreed upon standards or conventions.